We talked a bunch about how we made cinematics feel real, and the things we did to make gameplay motion feel real. But now let's talk about how we tried to blend the two to make the entire game a filmic experience. First, we tried to identify some of the obvious visual clues that you can tell gameplay from cinematics. We'll talk about transitioning between cinematics and gameplay, then we'll talk about gameplay into cinematics, and finally, how we try to keep a consistent style between the two. So what are some of these visual clues? Pre-rendered scenes, even rendered in the game engine, become apparent due to compression artifacts. So one of the big selling points for us was that everything had to be real-time. When games use different character models for cinematics and gameplay, there's a noticeable change in fidelity, from the resolution of the mesh to the use of different shaders applied to the character. We decided early on to use the exact same asset in cinematics and in gameplay to avoid any of these discrepancies. This had the added benefit of simplifying our pipeline because it meant we didn't have to manage two different assets. So another indicator is the camera. Obvious blends of the camera swinging into position or bad camera transitions also become recognizable indicators that the game has switched modes. And like cameras, obvious blends on the character also give away the illusion. And the last major difference is in the way that cinematics and gameplay are shot, and this will include lens choices, framing, and camera movement. So how do we approach transitioning from cinematic to gameplay? The first step was that we would just match the pose. And when we started, we didn't have all the gameplay systems we do now. So starting by matching the pose was really the best we could do. But just matching the pose by itself wasn't enough. During cinematics, we turned the collision off for characters to avoid any problems with the physics as the character moves and interacts with the environment. And this works great until you have to turn the collision back on for gameplay. The problem is, if the character was animated to be even slightly above the ground, once the cinematic ended, they would immediately start falling and then quickly land, creating a noticeable pop. And the opposite is true. If they're animated below the ground, they either get stuck on the floor, or the game would pop them upwards to move them to a valid position. What we would often do is animate the character to where we thought the character should end up, run the game, see where the game's collision code would actually put the character at the end of the cinematic. We would then take those valid positions and reanimate the character in Maya using our additive rig to that new location. Eventually, we got a code solution to help ease this, but the more accurate we could make it initially, the better the scenes ended up. And like the character, the camera also tended to blend back to a valid position if the camera was too close or too far once the cinematic ended. So once we animated the character to the right location without any pops, we would then compose and capture a new valid camera position. And using those values from the game, we would work backwards to make sure that the cinematic ended in that camera position. We had to pull these values from the game because, like the player, the camera uses its own collision and prediction. So this was our first example of our seamless transition from cinematic to gameplay. We had a number of playtesters put the controller down and watch the cinematic, and then end up sitting for a minute, not realizing that the game had actually started. So we consider this a great success. You can see on the top, we had the player not pressing on the stick, and on the bottom, the stick being held forward. And near the end of the project, we started not only matching the pose, but also using subtle blends. This meant we could cross-blend into the game state. Using subtle blends meant we could also break out sooner. So if the user was pressing forward on the stick, the character would start moving before the cinematic animation had finished, preserving some of the momentum instead of just settling. But because this feature came on late, unfortunately, we didn't really have enough time to tune all of our cinematics, but when it was used, it ended up being very successful. You can see on the top camera, Galahad continuing to settle with no input from the player, and on the bottom, the player breaking out of the cinematic early. So the final piece was how NPCs moved from cinematic to gameplay, and there was a number of ways we approached this. Like the player, we started with just matching end poses of the NPCs to their idle states. This, however, had the problem of characters coming to life as their AI would kick in once the cinematic animation was over. We had two solutions for this. One was to have the AI already active in the last shot, cutting their animation short. And this solved the problem of having them wake up, but it meant we couldn't really direct performance. The other was we started using phase blending. This allowed us to get a bit of character performance as they started pathing to their next location, and it resulted in a seamless transition that offered the best movement into the space. So here are some examples of phase blending in action. Ultimately, we used a mix of all three solutions in the game, depending on the situation. Unlike going from cinematics, which is a known state, to gameplay, going from gameplay to cinematics have a lot of unknowns. So there are three different ways that we would trigger cinematics. Interacts, where the player would hit a button to start the cinematic, trigger volumes, where the player would walk into a space in the game, and time triggers, where a condition would happen that started the cinematic. So let's go over interacts. Interact syncing occurs when a screen prompt is activated by the player. On activation, the character is blended and then synced to an object. Blending is the procedural animating of a character from one pose to another pose, where syncing is the process of translating and rotating the entire character to a specific location relative to the world. There are two major benefits of interact syncing. The first is that the player has control over when the cinematic is triggered, and the second is that because the cinematic is triggered at a specific location, we know exactly where the player is. Because the player is interacting with an object, we can also use this motion to motivate the first cut. Typically, we animate the character as close to the object as possible. If the player is too far from the starting location to just use syncing, we use AI to path them closer. This let our designers adjust the activation radius without animators having to go back and adjust the animation or the sync and blend times. So here you can see the character walk over to a position before he starts to open the door. We also wanted the weapons that the characters had in gameplay to carry over into cinematics. But trying to capture every different variation would have been extremely difficult. So instead, we would mocap our actors without weapons. We would then use the in-game holster animations to put their weapons away before beginning cinematics. And because the player is interacting with an object, it felt natural for the character to first holster the weapon to help free up their hands. Because we never know exactly where the camera is, we have to blend it. We found it was always better to blend forward into a scene or in the direction of the first cut than to blend backwards. So we would animate the camera closer than was valid for gameplay to make sure this happened. Trigger volumes are when the player would walk into a space. And unlike interacts, which are at specific points, trigger volumes are more like crossing a threshold. So not only is there a larger variation in location, but the player is also always moving into the trigger, which means there's a variation in how fast the player is going. To mitigate some of these unknowns, we would try to funnel the player by having the trigger happen either at doorways or when entering narrow spaces. And setting up these volumes at obvious thresholds had the added benefit of letting the player dictate when they were ready to progress forward. One of the easiest ways to start these cinematics was with a reverse shot once the player touched the volume. Cutting immediately and having the player move into the space did seem to work, but it's also very abrupt. When we needed a better transition, we would sync and blend the character into position. We could then cut once the action motivated it. The problem with this is that the character is moving, so we really needed to try to match the speed the character is going. It tended to work best when we would favor the player fully pressing on the stick and animate to that speed. The other thing we tried to do was to use the AI to start an action to help motivate the first cut. Here you can see the woman on the screen left start to wave to Galahad once he crosses the threshold. This helps motivate the cut. So the best advice I can give about time triggers is to avoid them whenever possible. Even when they work, you don't know which way the character is facing, which means a hard cut will come out of nowhere and can be extremely disorienting to the player. So here's an example we use to that effect, but you can also see that it breaks the continuity of the scene. The best option is to cut to something else first so you can then cheat where and what the player was doing. Here we have a couple examples of how we try to make both the gameplay and cinematics feel similar through editing and shot selection. Some of the things we did is we would use the same focal length for cinematics and gameplay. An example is cover and say, a mid-shot in a cinematic. More specific examples are using similar framing of shots. An example is the camera that follows Galahad in gameplay. The other is a similar treatment of how melee is done in both cinematics and in gameplay. So let's go over the follow cam in cinematics. When tracking with characters, we always try to be over the right shoulder and at a similar distance. Here we can see, even though we are transitioning to a cinematic, we try to echo the game camera as we follow Galahad through the door. Here's another example of how we use that same type of camera to move the player into cover to help make the transition seamless. We even use that shot in the middle of a cinematic whenever we are following the player running. In this cinematic, we use it multiple times, trying to keep both a similar distance and feel to the gameplay. And let's end with a montage of our melee takedowns. These were done by our gameplay team and really show how we integrated a lot of the cinematic principles into our gameplay.
And that wraps things up. We'd like to thank our incredible artists, programmers, and designers at Ready at Dawn, Sony Visual Arts Service Group, Sony Santa Monica, Naughty Dog, and Autodesk for making this game and this video possible. Thanks for watching.